38% of global energy-related emissions are because of the buildings. 8 out of the 38 is the construction, and 30 is the operational emissions. And if we want to be in a net zero world, removing that 38% is going to be a huge task. And how you make a carbon sink into the building is basically you need to electrify the building, especially with renewables.
Today I brought on Petri Laakso, CEO and partner of Soletair Power. Soletair Power enables buildings to capture CO2 while cutting energy costs. Not only does it capture carbon then mineralize into concrete, but the system also integrates with existing HVAC systems. Today we'll discover how Soletair Power transforms buildings into carbon sinks, as well as ventilation energy reduction, carbon credit economics, and CO2 capture technology at large. This is Earth ABC, featuring Petri Laakso. I came across this pretty crazy statistic, or two statistics. So first one is that 68% of the world's population is expected to live in cities by 2050. And 60% of those buildings that will exist by 2050 have yet to be built. What do we do with this information?
Well, yeah, it's a lot of buildings to be built. I mean, that we need to build, let's say, another set of buildings or even more based on your statistics. And we think that the cities are key to climate change. I mean, we spend most of the energy within buildings, and because of the climate change, the weather is getting hotter and hotter. So we need to do, let's say, air conditioning on top of ventilation in buildings. And we think that that's a key to things that how we can solve the climate change.
And what exactly do buildings play a part in, I guess, the world's population growing, world's population heading into the cities? And then you mentioned air conditioning and HVAC systems. So how do those come into play with all this?
Of course, when first of all, when we build buildings, we need to do materials. And typically, we use concrete to build buildings, and steel and these kind of things. And when you make concrete, you need cement, and production of cement is causing a lot of CO2 emissions. So if you could have an alternative solution, so that you use less cement to make the same concrete, you could save a lot of emissions there. And then when you build the buildings, when we need to be in net zero, you need to build those buildings in a way that you avoid as much as possible emissions. But actually, currently, the majority of emissions are coming from the energy utilization in buildings, meaning that when we generate electricity and we use it in buildings, in lighting, cooling, heating the building, ventilating. Ventilating means that you push air in and air out. And the air conditioning is one of the biggest chunks of energy consumption in buildings. So if we could reduce the ventilation and air conditioning, we could save energy. And our solution is about to capture the CO2 and making the ventilation less. So then you can create negative emissions through utilizing that captured CO2 in manufacturing concrete products and substituting part of the cement with that. So it kind of has benefits on top of benefits if you would do it this way.
Yeah, so there's like this aspect of improving like the ventilation, the energy utilization aspect, but then also when it comes to building these buildings, there is the ability to manufacture concrete in a more sustainable fashion. So with these like dual, I guess, benefits, what does Soletair Power kind of come into the picture?
Yeah, we come into the picture, like the company was founded 2016, and 2017 we pivoted to building ventilation, because outdoor CO2 capture, the benefit, what you do there is only the CO2 captured, and you can utilize it in a way of you sell it or you create carbon credits through mineralization, for example. But when we do this in building ventilation, one of the primary reasons why we ventilate in buildings is the dilution of CO2 that we as people exhale in buildings. So our solution is basically that we capture the CO2 from ventilation so that you kind of push in ultra fresh air in buildings. And this way you can lower down the ventilation speeds. And if you are in a climate zone which has a hot and humid climate, like in Singapore, for example, the humidity condensation takes a lot of energy. And if you just need to do half of that, you kind of save half the energy. So that is how we come into play. And then we would work with partners who utilize the CO2 in the mineralization. So that's also something what we need to do together with partners. That's not our kind of a focus.
Gotcha. And the term of carbon sinks comes up a lot when it comes to conversations about Soletair Power and what you guys are doing with DAC technology. So first question is, how can buildings be carbon sinks, and why does that matter?
Well, yeah. Let's start with why does it matter? 38% of global energy-related emissions are because of the buildings. 8 out of the 38 is the construction, and 30 is the operational emissions. And if we want to be in a net zero world, removing that 38% is going to be a huge task. And how you make a carbon sink into the building is basically you need to electrify the building, especially with renewables. And renewables still have a small emission then, because when you build solar panels and windmills, you generate emissions. So there's like embodied carbon. Same happens in buildings. When you build buildings, you have embodied carbon. So then you need to remove these two, and that you do by capturing CO2, reducing the energy consumption in building. You cannot reduce to zero, otherwise you cannot even build the building. So then when you use renewables, you reduce energy consumption, you capture CO2, and you do mineralization from that CO2 so that the CO2 never returns back into the atmosphere. You create negative emissions. And this way you can make a carbon sink. Of course, the sink is not within the same building. It's going to be probably on the next building that is to be built, or the infrastructure where we use concrete, for example.
Gotcha. So once we have the first building, then it's this domino effect of like more and more buildings can be built sustainably.
Yeah, and we already have a lot of buildings in the world. So if you would take all the buildings and the ventilation in them, you could already capture gigatons of CO2 today. So then basically by 2050, when we have another set of buildings, so to speak, the amount of CO2 to be captured is even more. We kind of have like a distributed CO2 capture ecosystem, what we envision to build globally, so that we have the system already existing. We would just need to utilize it, and when we do that, we would be saving a lot of energy while we do that.
Gotcha. And to give us a bit more perspective on the amount of CO2 that can be captured, how much CO2 can like one building, big or small, if you could provide like the context for that as well, how much can these like buildings capture?
Yeah, the capture rate comes from the fact that how much you ventilate. In here in Europe, you typically ventilate like 1.5 liters per second per square meter of office space. It depends whether you have a school or you have an apartment building or office, or so building to building, it's a bit different. But let's use that office building as a kind of a benchmark or reference. So then, for example, we built a system in Vaasa, Finland. It's like 2,000 square meters, and you can capture with our current system like 20 tons per year from that 2,000 square meter office space. So it's like 10 kilos per square meter per year. And if you use renewables to run the operations of that building, and you capture that 10 kilos, you should be close to zero at those settings. And when we start capturing with our next generation model even further, so then you can take it quite far on the negative side. But maybe that 10 kilos per square meter is a good reference number to be a kind of a remember.
Gotcha. And with these different like buildings, different sizes, different building types, so residential, commercial, industrial, there's a lot of different HVAC systems as well. So how does like your system integrate with existing HVAC systems in different building types?
Yeah, it comes from modularity of our solution. I mean that we can accommodate small airflows or higher airflows, depending how many modules we put into a building. It can be like in a bigger office building, one floor can be like some cubic meters of air per second. In some buildings, you may have tens of cubic meters per second ventilation units, and we just need to use the modularity to capture the amount of or treat the amount of air that is in the building. So it's like a universal solution. You just do it smaller or bigger to adapt it to that building, because you cannot match it to every different ventilation unit in the world as a separate device, but as a modular solution, that is possible.
Gotcha. I could definitely see the modularity of your system being an advantage to adapting to the building itself. And I know that there's various types of like operating conditions that could come about that are specific to like a particular building. So like temperature, humidity, outdoor CO2 levels. So what are the CO2 capture rates and then the purity of the captured CO2 under these various conditions?
Yeah, the beauty of capturing CO2 in buildings is typically that because of us people, you have like plus 20 degrees Celsius and the humidity is like, I don't know, 40 RH, roughly. No matter whether you are here in Finland in the winter or if you are in the Singapore well, there is always the same kind of conditions. Within a building, you always have roughly the same kind of conditions, and air is fairly clean in buildings. So it's a quite high stability environment to capture. And we typically dimension our system, if there's nothing special on the case, that 75% of CO2 going by, we capture. So let's say that the outdoor CO2 level globally is like 430. So if we capture like 75%, roughly 100 ppm will go into the building, for example. But if you are in a busy office building, you might have 1,200 ppm within the office. And if you recirculate the air and we capture the CO2 away, so you cut back like 800 ppm or something like that away when the air returns into the office. So that's about it. And if you want to have one number, you need to ventilate like 1.7 million cubic meters of air in order to capture roughly 1 ton of CO2. So pretty big numbers, let's say, but in an office building like that, 2,000 square meters, it's like 157 hours and it's done. So not that much.
Yeah. And in terms of the overall system, like let's say I'm a building owner, I'm interested in adapting it to whatever HVAC systems that I have. I want to know about the longevity of your system. So what does that look like?
Yeah, our previous version of the unit, the system lifetime is like more than 20 years because it's basic building infrastructure, kind of water pumps and these kind of things. So no moving parts except, of course, the fan if we install that. The sorbent lifetime, the adsorbent that captures the CO2, is several thousand cycles lifetime. And on the previous version, we captured 1 cycle a day. So it starts in the morning, it starts the whole office day, and then we do the removal of CO2 in the nighttime when the ventilation flow is low. So it's like 10 years lifetime easily. The new version that we are now bringing up to life is going to have a, let's say, 2-3 year lifetime because it's going to make more cycles per day. But the total cost of ownership, let's say, is going to be lower because there's a much lower amount of sorbent inside the system. So even though you exchange it, it's a couple of hours job to do the exchange every 2.5-3 years, and then you can just keep on running. And I would say that the performance of the direct air capture device is like solar panels. It decays slowly. So like after 10 years, the previous model is at 85% performance still. So it's not that it dies someday. It will just decay slowly as a performance-wise.
Gotcha. And what does maintenance of the system look like and any associated costs?
Yeah, actually, the maintenance is basically the adsorbent cost. So when you replace it, there's no other kind of a maintenance kind of thing. So of course you need to monitor that you don't have any leaks here and there. but that's like what you normally do in the building infrastructure. We have like a synergy between the building heating infrastructure, so we can take in the heat which is used to remove the CO2, and then we can give it back into the building. In Denmark, or the case that we are next building up, we will push it back into the building, floor heating, radiator heating, hot water production, and even the district heating return side. So we can kind of use the same energy a couple of times in the building. So that kind of makes our system more energy efficient.
Makes sense. In terms of lifespan, since we're still talking about that, and you mentioned earlier that you're capturing the CO2 and you're converting it to manufacture concrete. So with the concrete that you are then producing, what's like the expected lifespan of the material that you capture and turn into concrete, and what is like the, I guess, performance or quality of that produced concrete relative to just in typical procedures?
Yeah, sorry, I didn't answer your previous question about the quality of CO2. So the quality is typically like 99.5 or higher directly out of our system. But then there are methods that you can increase the CO2 quality up to food grade quality, so 99.999% purity. The mineralization of CO2 in concrete processes, that's our partners. There are several companies in this world, startups also, that make the process. And what they've said is that certain concrete components are more or less the same quality or standard as the traditional one. So there are a couple of ways you can make precasted concrete components where you can put in a lot more CO2 because of the curing phase. So it's like a kind of a chamber where you put the parts and you increase the CO2 level there, and the components eat the CO2 as normally happens also in the atmosphere. Or then if you use a ready mix concrete, that you can mix a little bit of CO2 there, and it doesn't have any effect on the quality of concrete. So basically, it's the same quality on the concrete as far as we've been told.
Gotcha. Okay. And as I was like looking through how you guys make money, so you have like energy savings, carbon tax reduction, carbon credits, higher rent yield. Can you provide a more detailed breakdown of these and the timeline for achieving ROI for your customers?
Yeah, currently for the next unit that we put to market next year, early next year, we see that in hot and humid climates like Singapore, that the timeline for the payback should be in the range of less than 2 years. Of course, it depends on the building, the energy consumption, and can we actually do the energy savings. And the breakdown is that when you capture the CO2, the carbon credits, if you mineralize the CO2, that's like a cherry on top of the cake. You can basically vent out the CO2 and you will just have a 2-month longer payback period. The rent increase, what we have in cases so far, is like 3% more rent. And why would somebody pay more rent for our customer is that when you make carbon net zero premises, that's more valuable than normal buildings. And many companies want to be net zero, for example, based on the Science-Based Targets Initiative. And then the interest rate benefit for the building owner when they build a new building, if you get a greener loan, that's like I don't know, like 20% of the business case. But the energy savings are the majority of a case there in Singapore. The energy savings is a bit less if you come here in the Nordics, where we don't have hot and humid climate, even though we have, let's say, cold temperatures in the winter, but still the energy consumption as a whole is much lower than in Singapore, for example.
Makes sense. And then I saw that you're also working with different folks with humid climates. So you have a HVAC unit in Hong Kong, if I'm not mistaken.
That is a project in the let's say planning phase. We've been calculating with a few potential clients, but we hope that we can still sign a deal within this year to Hong Kong. So it's not yet coming up, but we are quite determined to finish it within this year.
It's very interesting when it comes to like global expansion in general. What are some key like regulatory and market considerations in these like different regions around the world?
Yeah, of course, there are different certifications. For example, if we would go to US, install these, we would need to have a underwriters laboratories kind of certification. Within Europe, we can operate under the CE certification. That was the case also when we delivered the system to Dubai. So there are from country to country different kind of regulations, and also ventilation regulations are different in different places. So there's no like a uniform thing that what you can do in Denmark that you can copy to the different country. But so far we've been successful making things work for us.
Gotcha. And how are you actively engaging with these carbon credit markets specifically? Like, what's your strategy for maximizing the value of these credits for both Soletair Power and then your customers?
Yeah, I think I don't know how to maximize it, but of course, as much as you capture, and when you have a short transportation distance together with a partner, then you can kind of maximize it. What also makes the equation much better is that when you use renewable energy to run our system, and if we can kind of have the symbiosis between the building and our system, so that you can kind of exchange the energy, it will increase the energy savings potential. So that's probably the how we can do it together with a customer. And in for example, the case in Denmark, the building owner wants to utilize the carbon credits themselves. They are not selling them. They want to retire those so that they can calculate it as a net negative emission. So then they kind of have in their own mind the value for the carbon credit. So I think it's more valuable to create it yourself than buy it or sell it. But it depends on the case.
Gotcha. And it makes sense that if it's like a shorter distance of like transport, then it's just like the better or ideal situation. Do you guys currently have like your own manufacturing capability for like the capture units?
Yeah, we do that here in Finland. We do the final assembly and testing on our own facility, but we mainly subcontract most of the components. The key things we do here on our own factory or assembly site, but the majority of stuff is just subcontracted because we don't have a huge staff working, and when the projects come and go, we need to have let's say some flexibility on the manufacturing.
I see. And you have subcontractors and then the core team itself. And feel free to brag about your background, your accomplishments. But I'd love to spend time for you to highlight like the background experience of your core team in areas like carbon capture, HVAC systems, material science, business development, everything that are very important to your business.
Yeah, I think on our team, we have a long history and experience from several startups and exits creating similar type of devices. So there is experience how to grow from 0 to $100 million exit. So that's probably the first thing. Then many of our team members has been in-house already for quite some time and has a, let's say, relevant experience to make these kind of things. So we are determined to make it happen. And then on top of that, of course, the companies funding us and supporting us, the owners, Halton, Helkama, and Wärtsilä, they have a lot of connections and they can help us as owners to succeed in this market. So we are not just like a small startup doing it. Halton has factories globally in the HVAC business. Wärtsilä is an energy company operating globally. So through them we can get a valuable know-how also to our team to push through globally.
Mm-hmm. Sounds like with the global partners, team members with prior exits and a lot of extensive experience, that the team there is like really sound. And So far, it sounds like the technology that you guys have developed is really neat, provides a lot of dual benefits. In terms of the uniqueness of the product that you guys have, how is it that your technology is better than others in terms of efficiency, scalability, and cost effectiveness?
Yeah, I think there is like, I was just yesterday browsing LinkedIn, and there's like 150 DAC companies, and 100 previous one has stopped operations already. What's unique in Soletair Power is that we focus in buildings, and we can make those additional benefits so that we can actually reach net negative capture costs. So basically, when you're capturing CO2, you can make money instead of spending money to capture it. That's the biggest difference, and buildings are the key to this. Technology wise, I think our systems are small and modular, and we want to be there because of the application itself. Many DAC companies worry with the thing that they need to tailor the solution to, I don't know, Texas in US, and then Singapore, having different kind of environments, and Finland. We have just one environment. It's the indoor environment that we need to kind of focus on. So that's why we have a high stability environment as where we capture. So we don't need to tailor the unit geographically, that here it's a bit different than there. And with our system, we have a health and safety organization out of Finland. It's occupational health and safety organization here, has given us a certificate that the air coming through our device is healthy for people to inhale. So that's one that probably sets us different from many others. So I think there are many benefits. Plus we have the IP there, granted in US and here in Europe, capturing CO2 in buildings and reutilizing that CO2 later on. That's also valuable against other companies.
Most certainly. Okay, let's say I've listened to this entire conversation. I'm a building owner. I'm very interested in installing the system into my building. What's like the typical lead time and the timeline for installing the Soletair Power system in a new building I have, and then an existing building I have?
Yeah, we've done existing buildings so far, and even though we've been doing new buildings, we have been too late in the project. I mean, that the design has been ready, so we've been doing basically retrofit so far. Time from the order, currently like 6 months plus. We hope to regain next year, so 2026, 3 months delivery time. We would need to order in the critical components, which are long lead time items. So that is something that what we see typically in the discussions with a new client, takes a couple of months, because we need to check that where we can fit it, what's the benefit, how does it work in a building, where the CO2 goes. So unfortunately, quite a few things need to be settled first, so that they can be relaxed and make the purchase order, and then we start manufacturing the unit. So that's a rough timeline. Previously, it's been like a 1 year delivery time, roughly.
Gotcha. And it'll only get much more condensed with the years coming forward. That's pretty much all the questions that I had. I really enjoyed our conversation. I know by like 2050, there's going to be a lot more buildings that will exist. And this type of technology is definitely something that will help us get to that zero. So incredible learning opportunity for me, and opportunity for you to share more about Soletair Power and getting more of your DAC technology into these buildings.
Yeah, thanks. It was nice to be here, and I truly believe that we can revolutionize the building ventilation business, and there will be other companies also on the market quite soon, because this will be a standard in the market years to come.
Most certainly will be a standard. All right. Thanks again, Petri. Thanks for tuning in. If you enjoyed this interview, follow along on Earth ABC's LinkedIn to stay connected and never miss what's going on in climate tech. If you'd like to reach out or you're interested in coming on as a guest, feel free to connect with me, Sean Pack, on LinkedIn. We're always looking for inspiring ventures and founders in the climate space to feature on the show. Hope you enjoyed. Until next time.